Today we are going to discuss on VIP question chapter 10 wave properties of particle. Okay, so the wave property duality is a phenomenon where under certain circumstances the particles exhibits wave property and under other condition a wave exhibit properties of the particle. Okay, therefore based on the wave particle duality of the light, Louis de Broglie suggested that the matter such as electron and proton might also have the dual nature. Therefore, he proposed that for any particle of the momentum should have the wavelength given by lambda is equal to h over momentum, or momentum we can also change it become nv. Okay, and we also notice that actually our potential energy U is equal to kinetic energy. Okay, therefore the potential energy is equal to EV and the kinetic energy is equal to half NV squared. Okay, so V is equal to 2 EV over M and then square root. So we can substitute inside the equations here NV, okay, where finally we will get H over 2m EV, or we can write as H over 2mk. Okay, so these are the four equations that we will use to find the de Broglie wavelength. Okay, so we go to questions number 1 first. Okay, calculate the de Broglie wavelength for the electron move with the speed of 1.5 meter per second. Okay, where the questions number 1, they give you the value for the velocity. Okay, so we can use the second equations where the de Broglie wavelength is equal to h over nv. Okay, so we substitute in h is 6.63 exponent negative 34 over the mass of the electron. Okay, so the mass of the electron is 9.11 exponent negative 31 and the speed is 1.5. Okay, therefore the de Broglie wavelength for an electron is equals to 4.85 exponent negative 4 meter. So the answer is B. Okay, second questions. Calculate the de Broglie wavelength for an proton if potential difference is 2000 volt. Okay, so here is we want to find the de Broglie wavelength for the proton, and the question gives us the potential difference. So we can use the third equations to find the de Broglie wavelength, where de Broglie wavelength is equal to h over 2m EV. Okay, where h is 6.63 exponent negative 34, 2m, because this is a proton, so the mass of the proton is 1.67 exponent negative 27, and E is a value for the charge 1.6 exponent negative 19, and the potential difference is 2000. Therefore, the de Broglie wavelength for a proton is equal to 6.4 exponent negative 13 meter. So the answer is A. Okay, next is questions number 3. Okay, calculate the de Broglie wavelength for an electron with the kinetic energy of 10 joule. Okay, so since the questions give us the kinetic energy, we can use the fourth equations where the de Broglie wavelength is equal to h over 2mk. Okay, h is 6.63 exponent negative 34 over 2m, where m for an electron is 9.11 exponent negative 31, and k is the kinetic energy, where it's equal to 10 joule. So finally, the de Broglie wavelength for an electron is equals to 1.55 exponent negative 19 meter. So the answer is D. Okay, next question is number 4. In an electronic microscope, electrons with the de Broglie wavelength 0.01 nanometer, calculate the potential difference required. Okay, so here they already give you the de Broglie wavelength where it's equals to 0.01 nanometer, and the question asks us to determine the value for V. Okay, so we can use the third equation where de Broglie wavelength equals to H over SLIT 2 MEV. Okay, so we can substitute inside 0.01 nano, so I will convert it into exponent -9, and H is 6.63 exponent -34 over SLIT 2 M for an electron. So the electron is 9.11 exponent -31. E is the charge. Okay, and V is the unknown. Okay, so after pressing the calculator, the final answer for the potential difference is equals to 1.5 exponent 4 volt. So the answer is D. Okay, that's all for this topic, chapter 10. We'll continue with the next chapter, chapter 11. Okay, see you on next video. Bye.